figures is a way to describe numbers that show precision to scientists because they were measured. For example, if I said, how far away do you live from school? You might say, I live 7 miles from school. Whereas somebody else might say, I live 7.1 miles from school. The person who lives 7.1 miles might know with a greater degree of precision how far away they live, whereas 7 might be more general number. So, when we talk about significant figures, there are a few simple rules that we need to follow. Rule number 1 is that all the digits 1 through 9 are significant. So within any given number, we look for anything that's not a 0 and we count it as a significant figure. So the 2, the 3, the 8, and the 5 of this number are significant. Therefore, we say this number has 4 significant figures, or sig figs. We look at the next example. The 4, the 3, and the 9 are each a digit between 1 and 9. And so this value has 3 sig figs. Our final answer, or final example, has a 2, an 8, a 3, and a 4, all of which are digits that are between 1 and 9. Therefore, this number has 4 significant figures. Notice it doesn't matter how big the number is, or how small the number is, or if there's a decimal. As long as the number is a 1 through a 9, no matter where it falls, then we count that as a significant figure. Our second rule is about trailing zeros. Trailing zeros are zeros that come at the end of the number. So all of these examples have trailing zeros, which I'm going to underline because they're zeros at the end of a number. Now, trailing zeros are significant only if the number has a decimal. So if we look at the first example, the trailing zero that I underlined is significant because the number has a decimal. Now, all of the rules just keep building on each other. So the 2 and the 9 are still significant based on our first rule that any digit 1 through 9 is significant. Therefore, 29.0 has 3 sig figs. We look at our next example. These 2 zeros are both trailing zeros because they fall at the end of the number. The number has a decimal, therefore each of these zeros is significant, and based on our first rule, the 1 and the 8 are significant. Therefore, we have 4 sig figs in this number. Our next example, the 2 zeros are trailing zeros because they're at the end of the number, and we don't normally see a zero or a decimal at the end of a number like this in math class, and that's the difference between math and science and why we use things like significant figures. It tells us that that decimal is there because it's important. That number 0 and 0 at the end of 500 are significant. They're important. It is a measurement. It's not just an estimate. So these 2 zeros are significant because of that decimal. The 5 is significant based on our first rule, and therefore we have 3 sig figs. Our final example has a trailing zero, but in this case there's no decimal. Because there's no decimal, this zero is not significant. The 1 and the 2 are still significant based on our rules, but therefore this value or this number only has 2 sig figs, not 3. Now a lot of people ask, does that mean that 0 doesn't matter? No, there's a difference between whether or not we need the 0 and whether or not it's significant. For example, if you were 12 years old versus 120 years old, that 0 makes a big difference. So our number is still 120. That 0 doesn't just disappear. All we're saying is that it's an estimate. It's not exactly 120. Maybe I say something like somebody weighs 120 pounds. Well, if that person weighs 120 pounds, one day it might be 121, one day it might be 119. That's what that 0 not being significant means. It's that it's an estimate. We've rounded it. It's approximately 120. It's definitely not, though, 12. If we keep going, we have 2 more rules for our sig figs. So our next rule is about trapped zeros. Trapped zeros, or sometimes I like to call them sandwich zeros, are always significant, and that's because they're in between 2 significant figures. So if we go back to our first rule, all of our non-zero numbers are significant, and that 0 you can see is trapped in the middle of some check marks. That makes it significant. Therefore, we have 4 significant figures here. All of the these examples have trapped zeros. Therefore, we're going to have lots of sig figs here. Another 4 sig figs. 3 from the first rule, 1 from the trapped rule. Now this one is kind of like a double cheeseburger or a double sandwich. It has 2 trapped zeros. So the 5, the 1, and the 9 are significant based on our first rule. And then here's a 0 trapped between 2 sig figs. And this 0 is also trapped between 2 sig figs. So we have 5 sig figs total. Our final example, the 5, the 4, and the 2 are significant, with the 0 trapped in between being significant for a total of 4 sig figs. In these particular numbers, doesn't matter what the decimal is, doesn't matter as long as it is trapped between 2 non-zero numbers. Our final rule is about leading zeros. So we talked about zeros that trail at the end, zeros that are trapped in the middle, and now we have leading zeros that are at the very beginning of numbers. So we just underline them so that we know where those leading zeros are. So all of those are leading zeros because they're at the beginning of a number. These leading zeros are never, ever, ever significant. Again, that doesn't mean they're not important, it just means that they're not significant. Those zeros don't ever disappear, we just don't count them towards our total of sig figs. So all of these guys I'm going to X out because none of them count towards our total. So that means the 3 and the 4 count for 2 sig figs, the 5 and the 9 count for 2 sig figs, the 8 counts for just 1 sig fig, and the 1 and the 3 count for 2 total sig figs.